Hello, welcome to FlixWater YouTube channel. Today, I want to talk about an important topic, PFAS in water and how we can remove these harmful substances. PFAS, or per and polyfluorinated substances, are man-made chemicals that persist in the environment. They have been widely used in consumer products, firefighting foams, and industrial processes due to their non-stick and water-resistant properties. However, these same properties make them highly persistent in the environment and capable of accumulating in our bodies and the bodies of animals. The challenge with PFAS is that they dissolve in water and are not easily removed by traditional drinking water treatment technologies. But don't worry, researchers at the Environmental Protection Agency, EPA, have been studying various methods to effectively remove PFAS from drinking water. One of the most studied treatment methods for PFAS removal is activated carbon treatment. Activated carbon is a highly porous material that can absorb contaminants like PFAS. It is commonly used in drinking water treatment systems to remove organic compounds and synthetic chemicals. Granular activated carbon, GAC, has been shown to be effective in removing PFAS, especially longer-chain PFAS like PFOA and PFOS. However, it may not work as well for shorter-chain PFAS. Another type of activated carbon treatment is powdered activated carbon, PAC, which is smaller in size and can be added directly to water. While PAC is not as efficient as GAC in removing PFAS, it can still achieve modest removal percentages. However, the disposal of the sludge containing adsorbed PFAS remains a challenge. Ion exchange treatment is another option for PFAS removal. Ion exchange resins, made of highly porous materials, can attract and hold the contaminated substances. Anion exchange resins, AR, are particularly effective for removing negatively charged contaminants like PFAS. AR has shown high capacity for many PFAS, although it is generally more expensive than GAC. One promising approach is single-use AR followed by incineration of the resin, eliminating the need for resin regeneration and the associated waste stream. High-pressure membranes, such as nanofiltration and reverse osmosis, have proven to be extremely effective in removing PFAS. These membranes have a rejection rate of over 90% for a wide range of PFAS, including shorter-chain varieties. However, a drawback of this technology is the generation of a high-strength concentrated waste stream, which can be challenging to treat or dispose of properly. Considering the waste stream issue, high-pressure membrane technologies might be more suitable as point-of-use options for homeowners. Treating smaller volumes of water would result in a more manageable waste stream, easing concerns about disposal. In summary, there are several effective methods for removing PFAS from water, including activated carbon treatment, ion exchange treatment, and high-pressure membranes. Each method has its pros and cons, and the choice of technology depends on factors such as the specific PFAS present, water flow rates, and disposal considerations. It's crucial to address the issue of PFAS contamination in our water sources to ensure the safety and well-being of our communities. By staying informed and implementing appropriate water treatment measures, we can take a significant step toward reducing PFAS exposure and protecting our environment. Thanks for watching the video. Please subscribe to our channel for next topics or click to see the next videos on the right.